Hey guys, real short lesson today on three-dimensional figures. Okay, so we're going to talk about what a solid is. A solid is a three-dimensional 3D figure that encloses a space. A polyhedron is a solid whose faces are all polygons. So this is a polyhedron right here. Okay, and it encloses a space. You can see it's got a space inside this box right here. And we've got the parts. We've got the edge right here. Okay, an edge is a line segment where two faces intersect. So here's a face, is this shaded kind of bluish thing right here. Okay, a face is one of the polygon shapes of the side of this thing. So we've got two of them come together, the front and the left side come together here on the edge. Okay, and then you got a vertex. A vertex is just the corners. Okay, this has 8 vertices. A vertex is a point where 3 or more edges come together. So you got this edge, and this edge all come together at that vertex right there. And then a face is the flat surface of the polyhedron. So those are the parts of a polyhedron. Now, if it's got a dome or a curve on it, it's not a polyhedron, but it's still a solid. Okay, now on this one, you're supposed to find the number of faces, edges, and vertices of the solid. Now, this is what's called a triangular prism. Okay, so you always name a prism by whatever its base is. So the base is this yellow triangle right here. So the faces, okay, it's got 2 bases, okay, the 2 triangles, and then it's got 1, 2, and then 3 lateral faces. So this has 5 total faces. Okay, now next would be edges. Okay, this has the 3 top edges, the 3 bottom edges, and then 3 edges that are connecting the top to the bottom. So this has 9 edges. And then you've got vertices. Vertices is plural for vertex, and it's got 3 vertices on the bottom, and it's got 3 vertices on the top, so it's got 6 vertices. Okay, so very simple to do. Oh, come on. Luna the math cat wants to make an appearance today. So, okay, so there we go. We've got 5 faces, 9 edges, and 6 vertices. Okay, a prism is a polyhedron that has 2 parallel identical bases. And then the lateral faces are all parallelograms. So these things are prisms. Okay, this is called a pentagonal prism because it's got a base that's a pentagon. Okay, and it will always have, prism will always have 2 identical bases, so this pentagon and this pentagon down here are exactly identical, and then these rectangles on the sides are called the lateral faces, right here, lateral faces. Now, it says that they're parallelograms, okay, they can be parallelograms. Remember, a rectangle is a parallelogram. Most of the ones we deal with are just going to be rectangles, okay, and then this one here, this is a triangular prism. Okay, it's got the 2 triangular bases, and then it would have 3 lateral faces that are rectangles. And this is called a rectangular prism, or sometimes it's called a rectangular box. Okay, now it has 6 faces. And the thing is, since they're all rectangles, you can put whatever you want as the bases, but almost always what you do is you make the top and the bottom the bases, and then the other 4 sides are the lateral faces. Okay, now a pyramid is a polyhedron that only has 1 base. Okay, so the lateral faces are always triangles. The base can be whatever it wants to be, just like the bases can be whatever they want to be up here. So this is a square pyramid because the base is a square. This is a triangular pyramid because the base is a triangle. Now, that's called a tetrahedron, by the way. If you've ever played Tetris is made with shapes that have 4 squares in them. Tetra means 4 in Greek. And this just means 4 faces right here, tetrahedron. And probably the most famous pyramids of all time would be the Great Pyramids of Giza. Okay, so it has this square pyramid has a square for a base. It has 4 triangular lateral faces, and then this is called the vertex, where they all come together at the top. Okay, now these are all vertices. Okay, it's got 5 vertices, but this one's called the vertex with a capital T and a capital V, and this would be the vertex here. Now, if all these triangles are all exactly the same, which can happen, then the vertex, capital T, capital V, is just whatever one happens to be on the top. Okay, that's it. We're going to do 1 through 33 odd, and I will see you guys in class.